Alright physicists, so we're going to have a quick look at how to calculate the final velocity. Now we're going to be using variations on a formula that we already know, so you're going to have to get your head around rearranging an equation again. Okay, so there are two ways to calculate speed. We can assume that speed is constant, so we can use the average constant speed, and that's the simple one. So that's velocity or speed is distance or displacement over time, so v equals s over t. Or we can predict speed with acceleration, and this allows us to use an object which is changing speed, and we can break its travel up into separate sections where we know the acceleration is different, and we can use that to work out its speed. Or we can predict the speed at the end of travel or end of a period of acceleration. So if we want to ask the question, how fast will a skateboarder be going after a certain amount of time, we would use this formula. V equals u plus at. Now these are all symbols you've seen before, but what they mean are final speed equals the initial speed plus acceleration and time, times time. So initial speed plus acceleration times time. Now, for a short period of time, we can actually do this quite easily. We can draw it out if we want, or we can step it and just add it up in our heads. So here's our skateboarder, and he's pushing along this way at 2 meters per second squared. And what this means is, so that's his acceleration. And so what this means is that every second, his speed increases by 2 meters per second. Okay, so here he is. His starting speed is 0. He kicks off. After 1 second, he's at 2 meters per second. After 2 seconds, he's at 4. 3, he's at 6, and so on. Now, if you want to do this graphically, as a calculation, we'd have to use this equation. But how do we get that formula? How do we get that formula right there? So we start off with our acceleration formula, which you should already know, and you'll at least be familiar with, and we rearrange it. We want to get basically we want to get this v on its own. So we get rid of the t first, which means we multiply both sides by t. That leaves us with at equals v minus u. Alright, so to get rid of the u, we add u to both sides. So it's a minus u, so we add a u to both sides, and this gives us v equals u plus at. You see here they cancel out the minus plus the positive. So v equals u plus at. That's where that comes from. So here's our skater, and he's accelerating at 2 meters per second from the start. So u equals 0, alright, for 15 seconds. So how fast is he going at the end of that 15 seconds is what we want to know. So we just plug in the numbers. So v equals u plus at, which is 0 plus 2 meters per second squared times 15, or 15 seconds, and that gives us 30 meters per second. Now we want to play with the big boys, so let's talk at a rocket. Let's talk at some real speeds here, some real accelerations. So the rocket, in this case it's actually a shuttle, not a rocket. So the rocket takes off at 50 meters per second, so 50 meters per second squared. That's its acceleration. So how fast is it going? What's its velocity? Velocity is the key word there. After 60 seconds. So we put in our formula. Now we've got the little half arrows above because, you know, it's a vector at this stage. We're asking for velocity. So it's 0 plus 50 times 60, or 50 meters per second times 60, which is 3,000 meters per second up. So every single second after 60 seconds, if it stopped accelerating and stayed at that speed, every single second it would go 3 kilometers. Alright, and we know, by the way, that that's, from our previous discussions, that's not fast enough for a rocket to make it into space, so it's got to go keep accelerating beyond that. Alright, that's it for today. Top work.